The pattern revealed itself in darkness and fire across 3 months of dying ships. On August 9, 1942, USS Quincy burned off Savo Island with 840 men trapped below decks. She never got effective gunfire on the Japanese cruisers that killed her. On October 11th, USS Duncan broke apart south of Cape Esperance after taking a torpedo at 3,000 yards. Her 5-inch guns were still traversing toward target when the warhead detonated. On November 13th, 1 day after the battle that would change everything, USS Atlanta limped into Espiritu Santo with her fire control director shattered and 400 men dead. She'd been caught in a night surface engagement where American ships stumbled into Japanese formations at ranges under 5,000 yards, where torpedoes traveled faster than targeting solutions could be calculated. 14 American warships sunk or crippled between August and November. 14 ships that carried the most advanced fire control systems in any navy afloat. 14 ships whose crews died waiting for their guns to be told where to shoot. The question nobody was asking, the question that should have been shouting from every after-action report, was simple. Why can't we shoot faster? The answer lived inside a steel box 3 decks above the main battery aboard USS San Francisco, inside the Mark 37 fire control director, inside the mind of a second-class electrician's mate who'd been watching the pattern long enough to see what the officers couldn't. Robert Chen was 23 years old and had never expected to change how the United States Navy fought wars. He'd grown up in his father's electrical repair shop on Grant Avenue in San Francisco's Chinatown, a cramped space that smelled of solder and machine oil, where radios came to be resurrected and motors came to spin again. His father had taught him that every electrical problem had a logical solution if you understood the circuit completely enough. Trace the current, find the resistance, fix the connection. Chen had applied that philosophy to phonographs and vacuum cleaners and neon signs until April of 1940, when he'd walked into a Navy recruiting office and discovered that the same principles worked on fire control computers worth more than his father's entire building. The Navy had sent him to fire control school at Great Lakes, where instructors explained the marvel of the Mark 37 director. It was revolutionary technology, a system that could calculate firing solutions automatically, that could track targets optically and translate their movement into gun orders without human computation. Chen had excelled at understanding its electrical systems because he approached them the same way he'd approached every radio in his father's shop, methodically, completely, with respect for how current wanted to flow and what happened when you tried to make it do something it wasn't designed for. By the time USS San Francisco sailed from Pearl Harbor in June of 1941, Chen knew every relay, every motor generator, every amplifier tube in the ship's fire control system. He could trace circuits in his sleep. The other electricians came to him when something broke because Chen didn't just fix problems, he understood them. The officers respected his technical knowledge while maintaining the careful distance between commissioned and enlisted ranks, that invisible wall that divided men who gave orders from men who followed them. Some of that distance was regulation. Some of it was something else, something Chen recognized from growing up Chinese in America, the subtle way people acknowledged your competence while never quite seeing you as equal. Chen didn't mind. He wasn't interested in being seen. He was interested in keeping the fire control system operational, which meant understanding not just how it worked, but why it worked the way it did. The Mark 37 director sat high above San Francisco's main deck in an armored position that gave clear sight lines in all directions. Inside, it was cramped and technical and precise. Optical rangefinders for measuring target distance, gyroscopes for stabilizing the platform against the ship's motion, electrical computing circuits that transformed raw targeting data into firing solutions. The process was elegant. Operators tracked the target optically. Rangefinders measured distance. The director measured bearing and rate of change. All of this information flowed as electrical signals into the computing circuits. This was where the marvel happened, where the Mark 37 proved itself the most sophisticated fire control system afloat. The electrical signals fed into mechanical integrators' devices that looked like elaborate clockwork, all gears and cams and differential analyzers. These mechanisms physically moved to solve ballistic equations. They calculated where the target would be when the shells arrived. They accounted for the ship's speed and course. They factored in wind, projectile drop, the curvature of the Earth at extreme ranges. The mechanical integrators were analog computers built from brass and steel, and they could solve problems that would take a human calculator 10 minutes to work through. They solved those problems in 8 to 12 seconds. At 10,000 yards, against cruisers steaming predictable courses, 8 to 12 seconds was acceptable. The mechanical integrators calculated perfect solutions. The guns fired. Shells landed where mathematics predicted they would land. At 5,000 yards, against destroyers closing at 30 knots, 8 to 12 seconds was a death sentence. Chen had watched this play out 3 times in the 2 months since Guadalcanal turned the Solomon Islands into a graveyard. The first engagement happened in mid-September, during a night sweep north of Savo Island. San Francisco detected a Japanese cruiser at 7,000 yards. The optical operators acquired target bearing. Rangefinders locked distance. Chen monitored the electrical systems as the mechanical integrators began their calculation dance. Gears meshed. Cams rotated. The ballistic solution took shape inside precision machinery. 11 seconds passed. The solution arrived. The guns fired. By the time the salvo was in the air, the Japanese cruiser had altered course 30 degrees. The shells landed 400 yards astern, stitching white columns in empty ocean. The target disappeared into darkness before the mechanical integrators could process a second solution. San Francisco's guns never fired again that night. Lieutenant Stevens, the targeting officer, had been furious in a quiet, controlled way that was somehow worse than shouting. "I need solutions now," he'd said to the fire control crew. "Not in 10 seconds. Now." But the Mark 37 couldn't deliver now. It could deliver precise, accurate, magnificent ballistic calculations in the time it took a Japanese ship to slip away into darkness. The second engagement came in early October, a confused night action where American destroyers stumbled into a Japanese formation at 4,000 yards. Chen had watched the fire control system struggle to keep pace with combat tempo, multiple targets appearing and disappearing. The optical operators calling out bearings faster than the mechanical integrators could process them. The targeting officer's voice rising with frustration. "Fire control, I need solutions, now." Chen had delivered solutions as fast as the system could calculate them, but the enemy launched torpedoes while San Francisco's guns were still traversing. The ship dodged 3 torpedo tracks by emergency maneuvering that threw everyone against their stations hard enough to leave bruises. San Francisco never landed a hit that night. The fire control system was still grinding through its first solution when the engagement ended. The third engagement, in late October, had been worse because it proved that American doctrine had failed to account for Pacific reality. Fleet training emphasized long-range engagements, where the Mark 37's precision dominated. But Guadalcanal forced night battles at ranges under 5,000 yards in conditions where visibility dropped to hundreds of feet. Ships appeared out of rain squalls at torpedo range. The careful geometry of long-range naval combat collapsed into knife-fighting chaos. That night, San Francisco's fire control system had simply given up. Not failed mechanically, Chen's electrical systems functioned perfectly. But the tactical situation overwhelmed the system's ability to deliver solutions fast enough to matter. The mechanical integrators fell further and further behind combat tempo, until Lieutenant Commander Hayes ordered the ship to shift to local control, manual gun, laying by directors at each mount. Accuracy dropped to nearly zero. Without the sophisticated, ballistic calculations, gun crews were shooting at shapes in darkness, hoping for luck. San Francisco survived that night because luck favored her. Other ships weren't as fortunate. The after-action reports all showed the same pattern. American ships arriving at close range, American fire control systems lagging behind engagement tempo, Japanese torpedoes arriving before American guns could establish effective fire. Chen had mentioned this to Lieutenant Morrison, the ship's electrical officer, 6 weeks ago. He'd explained it carefully. Technically, The way his father had taught him to explain electrical problems to customers who didn't understand circuits. The issue wasn't the Mark 37's components. The issue was architectural. The mechanical integrators created an unavoidable delay. At close range, that delay killed ships. Morrison had listened with the polite attention officers gave to enlisted men's observations. Then he'd explained that the Mark 37 met all Navy specifications. Bureau of Ordnance had tested the system extensively. The delay Chen described was inherent to mechanical calculation. There was no way to make gears and cams think faster. Modifying the system would require bypassing safety interlocks, which risked electrical fires that could destroy the entire director. Besides, no enlisted electrician had authorization to modify fire control equipment. That required engineering approval from Bureau of Ordnance in Washington, which meant paperwork and testing and timelines measured in years, not months. Morrison hadn't been dismissive. He'd been reasonable, which was somehow worse. He'd been explaining why the regulations existed, why unauthorized modifications were dangerous, why Chen needed to maintain the equipment as designed and let engineers in Washington worry about improvements. Chen had left that conversation understanding two things with perfect clarity. First, the regulations were written for peacetime, when equipment modifications were matters of engineering improvement and budget allocation. Second, ships were dying in wartime, where the 12-second gap between target acquisition and firing solution was the difference between torpedoes in the water and guns on target. He'd walked back to his repair station and looked at the Mark 37 director with different eyes, not as equipment to be maintained, but as a problem to be solved. The mechanical integrators couldn't be made faster, Morrison was right about that, but they could be bypassed. A parallel circuit using electrical calculation instead of mechanical computation could generate approximate firing solutions in a fraction of the time. The accuracy would be lower, 85% instead of 98%. But 85% accuracy in 3 seconds beat 98% accuracy in 12 seconds when enemy torpedoes were already in the water. Chen had the technical knowledge to build such a circuit. He had access to components from damaged equipment. He had 40-hour maintenance windows when officer supervision was minimal. What he didn't have was authorization. What he didn't have was permission. What he didn't have was any way to build this circuit without violating every regulation in the Navy electrical manual. The regulations were there for good reasons. Unauthorized modifications could destroy expensive equipment. They could create safety hazards. They could get people killed if something failed at the wrong moment. Chen understood all of this because his father had taught him to respect electrical systems, to understand that electricity followed rules and breaking those rules had consequences. But Chen also understood that 14 ships had died in 3 months, that thousands of sailors had drowned waiting for firing solutions that arrived too late, that the pattern would continue until someone broke the pattern. He stood in the fire control director during evening watch on November 7, 1942, and made a decision that would either save lives or end his career. Possibly both. The regulations were written for peacetime, but ships were dying in wartime, and Chen knew how to make them stop dying. All it would cost was everything he'd worked for if he was wrong. All it would save was everything if he was right. The solution existed in Chen's mind as clearly as any circuit diagram he'd ever drawn in his father's shop. A parallel calculating system using vacuum tube amplifiers instead of mechanical integrators. Pure electrical computation trading precision for speed. The mathematics were simpler than what the Mark 37's mechanical calculators performed, but they were fast, nearly instantaneous compared to gears and cams grinding through ballistic equations. The core principle was approximation. The mechanical integrators calculated exact solutions accounting for dozens of variables: projectile weight, muzzle velocity, air density, wind speed and direction, target course and speed, ship's course and speed, parallax correction, Coriolis effect. Every variable refined to produce firing solutions accurate within 2 mils. Beautiful mathematics, deadly slow. Chen's electrical circuit would ignore half those variables for the initial solution. Approximate the ballistics using standard conditions. Assume sea level air density. Skip the Coriolis correction at ranges under 10,000 yards where it barely mattered. Calculate target motion using simple geometry instead of differential equations. The result would be crude 80 to 85% as accurate as the full mechanical calculation. But it would arrive in 3 seconds instead of 12. 3 seconds to get shells in the air. Then the mechanical integrators could catch up with refined solutions for subsequent salvos. The first shots would be approximate. The follow-up shots would be precise. But in a close-range night engagement where ships appeared and disappeared, in minutes, getting that first salvo out fast enough meant the difference between hitting the target and watching it vanish into darkness. The technical challenge was building this circuit from nothing using components Chen wasn't authorized to requisition. The Mark 37's electrical systems used specific military-grade vacuum tubes, precision resistors, heavy-duty relays, rated for sustained combat operations. Chen couldn't walk up to the ship's supply officer and request 24 amplifier tubes for an unauthorized fire control modification. The paperwork alone would trigger questions he couldn't answer without admitting what he planned to do. But San Francisco had been in combat for 4 months. Combat broke equipment. Damaged electrical systems came back to Chen's repair station, where he salvaged what he could and marked the rest for disposal. Over the past 6 weeks, Chen had been very careful about what he marked for disposal and what he kept in the repair locker for future use. A burned-out motor controller from a damaged 5-inch mount yielded 6 vacuum tubes whose filaments still tested good. An electrical panel that took shrapnel damage during a strafing attack gave him a dozen relay switches. A fire control junction box destroyed when a near miss rattled the ship contributed resistors, capacitors, and 12 feet of shielded wire. None of it was officially missing because it all came from equipment already damaged beyond official repair. Chen was just being thorough about salvage, keeping components that might be useful someday. Someday arrived on October 15th when San Francisco pulled into Espiritu Santo for a 72-hour maintenance period. 3 days when the ship would be anchored, when battle stations would be secured, when Chen would have access to the fire control director without constant officer supervision. He had 40 hours to build and install a parallel calculating circuit that would either revolutionize American naval fire control or destroy his career. Possibly both. Chen began after midnight on October 16th during the midwatch, when most of the crew was asleep and the duty officer was focused on security rounds. He'd moved his salvaged components into the fire control director earlier, disguised as routine maintenance supplies. Now he stood alone in the cramped space surrounded by the Mark 37's electrical cabinets, holding a circuit diagram he'd drawn from memory and hidden in his tool bag. The installation location was critical. The circuit needed to intercept target data before it reached the mechanical integrators, perform its calculations, and feed approximate solutions directly to the gun, train, and elevation motors. But it also needed to look like standard equipment, in case someone inspected the director. Chen chose existing electrical cabinets that already held amplifier banks and relay systems. His additions would nestle between legitimate components, wired to look like factory installations. The work required absolute precision. One misplaced wire could short the entire fire control system. One incorrect resistor value could send wrong voltages to the gun motors, potentially causing mechanical damage. Chen's hands moved with the careful confidence his father had taught him. Measure twice, cut once, test everything before you power it up. The vacuum tubes mounted into modified sockets behind existing equipment. Chen wired them to intercept optical rangefinder signals and bearing data. The electrical current representing target range flowed into a voltage divider circuit that performed simple division range divided by projectile velocity equals flight time. The bearing rate signal fed into a differentiation circuit that calculated how fast the target was moving across the ship's field of view. Simple electrical calculus using components that responded at nearly the speed of light, instead of mechanical integrators that responded at the speed of rotating brass gears. Chen worked through the night, soldering connections, mounting components, routing wires through existing cable runs, so everything looked intentional. The physical installation was only half the challenge. The other half was making the circuit invisible to casual inspection. He couldn't do it alone. At 0300, Electrician's mate third class Tommy Reeves found Chen elbow deep in an electrical cabinet with components spread across the deck. Reeves was 20 years old, from a small town in Oklahoma, had been assigned to San Francisco's electrical division for 8 months. He was competent, careful, and smart enough to understand immediately that Chen was building something unauthorized. "What are you doing?" Reeves kept his voice low, glancing toward the director's access hatch. Chen didn't look up from the circuit he was wiring. "Solving the 12-second problem. By building unauthorized modifications to million-dollar fire control equipment." Reeves moved closer, studying Chen's work. "This is court-martial territory, Chen. I know. I mean serious court-martial. Destruction of government property. Disobeying direct orders. They could give you 5 years in Portsmouth." "I know." Chen finished soldering a connection, inspected the joint, moved to the next one. "How many ships have we lost since August?" "That's not." Reeves stopped. 14. 14 ships, Chen said. "Thousands of men. Because our fire control systems can't keep pace with close-range night combat. I can fix that. But I need help. I need someone to hand me tools and components while I'm inside these cabinets. I need someone to double-check my circuit calculations. I need someone to test voltages while the system's powered up. And if it doesn't work? If it burns out the director? If the ship loses fire control in the middle of a battle because your unauthorized circuit shorts everything out?" Chen finally looked at Reeves. "Then I'll take full responsibility. I'll testify you were just following my orders, that you didn't know what I was building. But Tommy, it will work. I've tested every component. I've calculated every load. I know this system better than the engineers who designed it. It will work." Reeves was quiet for a long moment, looking at the partially installed circuit, at Chen's methodical work, at the technical precision that suggested Chen knew exactly what he was doing. "I'm just handing you tools," Reeves said finally. "I don't know what you're building. If anyone asks, I was helping with routine maintenance." "Plausible deniability." "Exactly." Reeves picked up a set of needle-nose pliers. "What do you need first?" They worked through the remainder of the night watch and into the morning, Chen installing and wiring while Reeves supplied components and verified connections against Chen's hand-drawn schematics. The circuit took shape inside existing electrical cabinets like a ghost hiding in legitimate machinery. Vacuum tubes arranged in parallel banks for redundancy. Relays configured to switch between the official calculating system and Chen's fast approximation circuit. Resistor networks that shaped voltages into the precise values needed for ballistic calculations. The dangerous part was bypassing the safety interlocks. The Mark 37 had multiple layers of protection against electrical faults, circuit breakers, thermal cutouts, ground fault detectors designed to shut down the system before damage could spread. Chen's parallel circuit operated outside those protections. If something shorted, if a tube arced over, if any component failed catastrophically, there was a real possibility of electrical fire. The kind of fire that could spread through the director, destroy the entire fire control system, potentially kill everyone inside the armored position. Chen knew this risk intimately. He'd seen electrical fires in his father's shop, had learned how fast they could spread, how difficult they were to extinguish. He built his circuit with that knowledge, using heavy-gauge wire rated for twice the expected current, mounting components with extra spacing to prevent arc over, installing the tubes in positions where they had maximum cooling airflow. It wasn't as safe as a Bureau of Ordnance-approved design, but it was as safe as Chen could make it given the materials and time available, and Japanese torpedoes were more dangerous than electrical fires. By 0600 on October 17th, the installation was complete. Chen stood back and examined his work with the critical eye his father had taught him to use. The circuit looked like it belonged there. Wiring was neat and professional, following the same routing patterns as factory installations. Components mounted securely, using standard brackets and hardware. The only addition that might raise questions was a small toggle switch Chen had installed behind a standard control panel, the switch that activated the ghost circuit. He labeled it AUX Calc in neat lettering that matched the other switch labels. Auxiliary calculation, vague enough to avoid suspicion, accurate enough to remind Chen what it did. Reeves helped Chen clean up the installation area, removing wire scraps and packaging, stowing tools back in their assigned locations. By 0700, when the day watch arrived, there was no evidence that anything unusual had happened overnight. Just 2 electricians finishing routine maintenance, the way electricians always finished routine maintenance. Chen didn't power up the circuit immediately. First, he traced every connection one final time with his voltmeter, verifying continuity, checking for shorts, making absolutely certain that throwing that toggle switch wouldn't cause immediate catastrophic failure. The testing took 6 hours, spread across 2 days, done in small increments during normal maintenance periods, when Chen had legitimate reasons to be working inside the electrical cabinets. On October 19th, satisfied that the circuit was sound, Chen waited for a scheduled gunnery drill. San Francisco conducted regular training exercises even while in port, keeping crews sharp, testing equipment, maintaining readiness. The drill that afternoon included fire control tracking of a towed target at 6,000 yards. Chen stood at his station inside the director, one hand near the auxiliary calculation toggle switch, watching the mechanical integrators grind through their normal solution process. Lieutenant Stevens called for a firing solution. The optical operators tracked the target. Rangefinders locked on. Chen flipped the toggle. His ghost circuit activated with a barely audible hum as vacuum tubes warmed to operating temperature. Electrical current flowed through his approximation circuits. Range data divided by velocity constants. Bearing rates differentiated into target motion vectors. Simple ballistic equations solved in parallel by banks of amplifier tubes. 2.9 seconds after Stevens called for the solution, Chen's circuit delivered gun orders to the train and elevation motors. "Solution ready," Chen reported, his voice steady despite the adrenaline flooding his system. Stevens didn't comment on the speed. Officers expected fire control to deliver solutions. The specific timing wasn't something they monitored closely. Batteries test fire. The 5-inch guns traversed smoothly to the calculated bearing and elevation. In an actual engagement, they would have fired. In this drill, they simply tracked the solution while observers recorded the accuracy. Chen watched through the director's optics as his calculations were measured against reality. The gun pointing wasn't perfect, about 15 mils off ideal, but it was well within combat acceptable range. Close enough to land shells within 200 yards of a maneuvering target at 6,000 yards, close enough to hit. The drill continued for 12 minutes, with Chen's circuit delivering solution after solution, each one arriving in under 4 seconds, each one accurate enough for combat use. The mechanical integrators continued their normal operation in parallel, eventually catching up with refined solutions that corrected Chen's approximations. But the important thing was speed. The ghost circuit got the guns on target fast. The mechanical system kept them there precisely. Lieutenant Stevens finished the drill, satisfied with the director's performance. "Good work. Fire control," he said over the intercom. "Some of the fastest solutions I've seen from this system." He didn't ask why, didn't question the speed. Assumed the official equipment was simply having an excellent day. Chen powered down the ghost circuit, flipped the toggle back to normal operation, and felt something relax in his chest. The circuit worked. Under conditions close enough to combat, with realistic target motion and time pressure. His unauthorized modification had performed exactly as calculated. Reeves caught his eye across the director and gave the smallest nod of acknowledgement. They'd done it. They'd built a circuit that violated regulations and solved the problem that was killing American ships. Now they just had to hope they got a chance to use it before someone discovered what they'd done. San Francisco remained in port for one more day, then departed Espiritu Santo on October 21st as part of a cruiser task force heading north toward the Solomon Islands. Intelligence reports indicated major Japanese naval activity around Guadalcanal. Both sides were reinforcing. Both sides knew a decisive confrontation was approaching. The ship settled into wartime routine: 4 hours on watch, 4 hours on standby, 4 hours for sleep if you could manage it. Chen maintained both systems now, the official fire control equipment and his ghost circuit. He tested components during maintenance periods, verified connections, made certain everything would work when needed. The officers remained confident. San Francisco had survived 3 night battles. Her crew was experienced. Her fire control was reliable. They had every advantage except the one they didn't know: they'd gained 3 seconds that might determine who lived and who died when ships met in darkness. On November 7th, intelligence confirmed a major Japanese convoy approaching Guadalcanal with heavy cruiser escort. Admiral William Halsey ordered every available ship north to intercept. San Francisco would be there. So would 13 other American warships. So would a Japanese force of similar size. They would meet somewhere near Savo Island in the early hours of November 13th, in the same waters where American ships had burned in August. In the same darkness that had favored Japanese night-fighting tactics for 4 months. Chen checked his ghost circuit one final time on November 12th, as San Francisco steamed north at 20 knots. Every connection solid, every tube testing good, every relay responding, the toggle switch waiting behind its panel. 3 inches of movement that would either vindicate his unauthorized engineering or destroy his career. He thought about his father's electrical shop, about the careful work of tracing circuits and understanding current flow, about the principle that every electrical problem had a solution if you understood the system completely enough. Chen understood the Mark 37 completely. He understood what it could do and what it couldn't do and what it needed to do to keep ships alive in close-range night combat. In less than 24 hours, his understanding would be tested in conditions where mistakes meant torpedoes in the water and men drowning in burning oil. The regulations said he should have waited for authorization from Washington. But Washington was 6,000 miles away, and Japanese destroyers were 6 hours away, and Chen's ghost circuit was ready. Sometimes the solution required breaking the rules. Chen just hoped he was right. The radar contact appeared at 0628 on November 13, 1942, as a cluster of green blips on the surface search display 18,000 yards northwest of San Francisco's position. 13 American warships steaming in column formation toward Guadalcanal. An unknown number of Japanese vessels coming south. They would meet somewhere in the black water off Savo Island, where visibility dropped to less than 1,000 yards and starlight couldn't penetrate the tropical overcast. Chen stood at his station inside the Mark 37 director, feeling the ship's vibration through the deck plates. 25 knots of forward speed, driving San Francisco toward contact. Around him, the fire control crew moved through pre-battle checks with the focused calm of men who'd done this before. Optical operators adjusting rangefinders. Radar technicians monitoring their scopes. Targeting calculations running through systems that had kept the ship alive through 3 previous night actions. None of them knew about the toggle switch hidden behind Chen's control panel. The switch labeled ARCS Calc in neat lettering. The switch that would activate a circuit that either validated 4 weeks of unauthorized work or proved Chen had wasted his career on a solution that didn't solve anything. The radio circuit crackled with tactical communications. Admiral Daniel Callahan, commanding Task Force 67 from San Francisco's bridge, coordinating 13 ships through water that radar showed was about to become very crowded. The American formation tightened as range decreased. 16,000 yards, 14,000, 12,000. Ships preparing for surface action at ranges where torpedoes outran, radio communications and decisions had to be made in seconds rather than minutes. Chen's right hand rested near the toggle switch. His left monitored the electrical systems, all readings normal, all circuits operating within specifications. The mechanical integrators waited in their housings, precision gears ready to calculate perfect firing solutions at peacetime speeds. The ghost circuit waited in its hidden installation, vacuum tubes warmed and ready to calculate approximate solutions at wartime speeds. At 0639, radar contacts resolved into individual targets. Multiple ships, range 10,000 yards and closing. The American column began a turn to port, trying to cross the Japanese formation's T, the classical naval maneuver that brought maximum guns to bear while limiting enemy response. But visibility was too poor for classical maneuvers. Ships were shapes in darkness, identified by silhouette when they appeared at all, more often just radar contacts that could be friendly or hostile until someone got close enough to see. At 0642, everything compressed into immediate violence. A star shell burst above the formation, chemical white light revealing ships scattered across 2,000 yards of ocean. American destroyers. Japanese cruisers. Someone's attempt at illumination creating confusion instead of clarity, because now everyone could see everyone, and nobody could be certain who was where. Chen saw the Japanese destroyer through the director's optics at the same moment the targeting officer did. Long hull, raked funnels, torpedo tubes visible in profile at 4,200 yards bearing 275 relative. The silhouette identified her as a Shiratsuyu-class destroyer, probably Yudachi based on intelligence reports. 35 knots capable, 8 24-inch torpedoes, reputation for aggressive night tactics. She was closing angle, her bow pointed directly at San Francisco's beam, range decreasing at combined closure rate of 50 knots. Torpedo range in 90 seconds, firing position in 60. Lieutenant Stevens's voice cut through the fire control circuit with controlled urgency. Fire control! I need a solution now. Target bearing 275, range 4,000, designate target Alpha. This was the moment, the exact tactical situation Chen had been preparing for. Close range, fast target, immediate action required. The mechanical integrators would need 10 to 12 seconds to calculate a proper firing solution. Yudachi would need 11 seconds to reach optimal torpedo range. The mathematics were simple and fatal. Chen flipped the toggle switch. The ghost circuit activated with a hum barely audible beneath combat noise. Electrical current surged through vacuum tubes Chen had salvaged from damaged equipment, through relay switches he'd scavenged from disposal bins, through circuits he'd hand-wired during 40-hour maintenance periods while the Navy slept. The auxiliary calculation system came alive doing exactly what Chen had designed it to do, calculating approximate firing solutions at electrical speed instead of mechanical speed. Range data from the optical rangefinder. 4,200 yards, converted to electrical voltage, fed into Chen's voltage divider circuit. Simple division range divided by projectile velocity equals flight time. 8.4 seconds for 5-inch shells to traverse 4,000 yards. The circuit solved this in microseconds. Bearing rate from the director's gyroscope. Target crossing left to right at 0.03 radians per second. Chen's differentiation circuit converted this into target angular velocity. More electrical calculus, more microsecond solutions. The circuit calculated lead angle, how far ahead of the target's current position the guns needed to aim to hit where the target would be when the shells arrived. Target speed estimation from visual tracking. Approximately 32 knots based on the bow wave and wake patterns visible through the optics. Chen's circuit used this to refine the lead calculation. Fast target, aggressive approach. Predictable course because Yudachi was setting up for torpedo launch and couldn't maneuver much without spoiling her attack geometry. The ghost circuit synthesized all this data using approximations that would make a Bureau of Ordnance engineer wince. It ignored wind deflection because the range was short enough that wind barely mattered. It ignored Coriolis effect because they were too close to the equator for Earth's rotation to significantly affect trajectory. It assumed standard air density and temperature. It calculated using simplified ballistics that treated the shell's flight as a parabola instead of the complex three-dimensional curve that accounted for rotation and drag. Every approximation sacrificed accuracy. Every simplification introduced error. The solution wouldn't be perfect, but it would be fast. 2.8 seconds after Stevens called for the solution, Chen's unauthorized circuit delivered gun orders to the train and elevation motors. Solution ready. Chen reported, his voice steady despite the adrenaline, despite the knowledge that he'd just activated equipment that could earn him a court-martial, despite the fact that 14 ships had died, and he was betting his career that he could help prevent 15. Stevens didn't question the speed, didn't pause to wonder why the solution had arrived in under 3 seconds. He saw firing data on his display and ordered the guns to shoot because that's what you did when enemy destroyers were approaching torpedo range. San Francisco's 5-inch guns fired in a rippling salvo that lit the darkness orange and sent 6 shells downrange at 2,600 feet per second. Chen watched through the director optics, counting seconds, tracking Yudachi's profile against the dark water. 8 seconds flight time. The shells would arrive before his circuit could be evaluated, before anyone could measure whether his approximations were close enough. The first 3 shells missed, passing just ahead of Yudachi's bow. Chen's lead calculation had been slightly aggressive, but the second 3 hit. Orange flashes erupted along the destroyer's superstructure as 5-inch projectiles detonated against steel. 1 shell struck near the forward stack. Another hit the bridge structure. The third impacted somewhere amidships. Not perfect shooting, 1 hit per 2 shells fired, but accurate enough at 4,000 yards against a fast-moving target. Accurate enough that Yudachi immediately turned hard to port, abandoning her torpedo approach, making smoke to break contact. "Target maneuvering!" Stevens's voice carried satisfaction. "Fire control, continuous solutions, walk them in." Chen's circuit was already calculating the second solution. Yudachi's turn changed her bearing rate, changed her aspect, changed everything the mechanical integrators would need to recalculate from scratch. But Chen's electrical approximation circuit just adjusted voltages and recalculated. 3.1 seconds later, the second firing solution arrived. The guns fired again. 2 more hits. Yudachi was burning now, her upper works torn by 5-inch shells, her torpedo attack completely disrupted. She disappeared into her own smokescreen trailing fire. Stevens keyed the intercom to the bridge. "Target Alpha, neutralized, ready for reassignment." Admiral Callahan's voice came back immediately. "Fire control, new target. Japanese cruiser bearing 310, range 6,000. Designate target Bravo." Chen swung the director to the new bearing. Through the optics he could see a larger silhouette heavy cruiser, probably Hiei or Kirishima, based on the Pagoda superstructure. 6,000 yards was longer range, but Chen's circuit handled it the same way. Approximate the ballistics. Simplify the calculations. Trade precision for speed. The Ghost circuit delivered a solution in 3.4 seconds. The guns fired. The mechanical integrators were still calculating their first solution when San Francisco's 5th salvo was already in the air. This was the chain reaction Chen had hoped for, but hadn't been certain would happen. Fast-firing solutions meant more shells on target. More shells on target meant more hits. More hits meant more enemy ships damaged or forced to break contact. The tactical advantage of 3-second solutions compounded with every engagement. But there was a price. Inside the electrical cabinets, Chen's salvaged vacuum tubes were running hot. The tubes were designed for intermittent operation, not sustained combat calculation. Heat built up in the glass envelopes. The relay switches cycled faster than their rated specifications. The resistor networks carried current loads they were barely rated to handle. Chen could smell burning insulation starting to seep from the cabinets, that distinctive electrical fire smell his father had taught him to fear in the shop. Tommy Reeves noticed it too. "Chen, something's overheating." Chen's fingers moved across his monitoring panel, checking voltages. The Ghost circuit was operating at the edge of thermal limits. Another few minutes of sustained operation and components would start failing, possibly catastrophically. But San Francisco was in the middle of a surface action. Japanese ships all around. Multiple targets identified. The bridge calling for continuous fire control solutions because the ship was finally achieving the kind of gunnery effectiveness that American doctrine promised but rarely delivered in night combat. Chen made a calculation that had nothing to do with ballistics. He reduced power to 3 of the 6 vacuum tube banks, taking them offline for cooling. The ghost circuit could operate with 50% capacity. Solutions would take 5 seconds instead of 3, still faster than the mechanical integrators. The trade-off was reduced reliability, increased stress on the remaining tubes, higher risk of cascade failure. But the alternative was shutting down the circuit entirely and going back to 12-second solution times. The smell of burning insulation decreased. The electrical loads stabilized. Chen's unauthorized circuit continued operating, delivering approximate firing solutions that let San Francisco's guns fire every 12 seconds instead of every 24. The difference was devastating for Japanese ships. Over the next 6 minutes, San Francisco engaged 4 separate targets. The Japanese cruiser took multiple hits and turned away burning. 2 destroyers attempting to close to torpedo range were met with accurate gunfire that disrupted their approaches. A 3rd cruiser exchanged salvos with San Francisco at 5,000 yards. And while both ships took damage, San Francisco's faster firing rate landed more hits. But the larger battle was chaos that no fire control system could manage. Ships interpenetrated American and Japanese formations. Friendly fire risks everywhere. San Francisco took hits from Japanese 8-inch shells that tore through her superstructure, destroyed radar antennae, killed men on the exposed bridge. Admiral Callahan died at his post when a shell detonated near the flag bridge. The executive officer assumed command while damage control parties fought fires and sealed breaches. Through it all, Chen kept his ghost circuit operating. The Mark 37 director survived the shell hits. The electrical systems remained powered. The unauthorized modification continued, calculating approximate solutions that let San Francisco's guns maintain firing rate even as the ship absorbed punishment. At 0651, 8 minutes and 23 seconds after first contact, the Japanese fleet began withdrawing. Not a decisive retreat, more a mutual breaking of contact by forces that had savaged each other at ranges where neither side could maintain cohesion. Ships dispersed into darkness, some burning, some damaged, all having survived night surface combat that was supposed to favor Japanese tactics and training. At 0652, Lieutenant Stevens ordered cease fire. The guns fell silent. The ghost circuit powered down. Chen's unauthorized modification had survived 9 minutes of sustained combat operation, had delivered approximately 60 firing solutions, had kept San Francisco's guns in action at rates that should have been impossible for Mark 37 fire control equipment. Chen slumped against his station, hands shaking with adrenaline drain, the smell of hot electronics filling the director. Around him, the fire control crew was checking equipment, assessing damage, beginning the post-engagement routine. Nobody seemed to notice that their solution times had been impossibly fast. Nobody questioned why the system had performed better than it ever had before. Tommy Reeves met Chen's eyes across the director. His expression said everything. We're alive. It worked. And we are absolutely going to get court-martialed for this. Chen nodded slightly. Probably true on all counts. But San Francisco was still afloat. Still fighting, had accounted for at least 3 enemy ships damaged or sunk based on visual observation of hits and fires. The unauthorized circuit had done exactly what Chen designed it to do. The evidence of that success was already being recorded. Every firing solution logged with timestamps. Every gun order documented. The gunnery records would show fire control performance that exceeded Mark 37 specifications by factors that couldn't be explained by good luck or crew excellence. Someone would ask questions. Someone would investigate. Someone would discover the toggle switch labeled AUX Calc and trace the circuits and find Chen's unauthorized modification hidden inside legitimate equipment. But that would happen later. Right now, as dawn started to grey the eastern sky over Guadalcanal, San Francisco was conducting damage assessment. 14 American ships had entered the battle. 2 had been sunk, several more badly damaged, but the Japanese convoy had been turned back. Guadalcanal would be reinforced. The night surface action that was supposed to favor Japanese tactics had ended in American tactical victory. Chen powered down his monitoring panel and began the post-engagement electrical systems check. The ghost circuit had survived combat, but barely. Multiple vacuum tubes would need replacement. Several relay switches had welded contacts from overcycling. Insulation damage throughout. The circuit would need complete rebuilding before it could be used again. That assumed anyone would let him use it again, once they discovered what he'd done. Lieutenant Commander Hayes's voice came over the intercom, calm despite the chaos. Fire control, secure from battle stations. Damage control parties maintain readiness. All section leaders prepare preliminary after-action reports. After-action reports, where gunnery performance would be documented, where solution times would be analyzed, where someone would notice that San Francisco's fire control had operated at speeds the Mark 37 wasn't capable of achieving. Chen looked at the toggle switch one more time. 3 inches of movement that had changed how one American warship fought at night. Whether it would change how the entire Navy fought would depend on what happened when the questions started. He suspected the questions would start very soon. Lieutenant Commander Hayes found the impossible data in San Francisco's gunnery logs on November 14th, while the ship limped toward Espiritu Santo, trailing damage. 47 firing solutions delivered during the 9-minute engagement. Average solution time, 3.2 seconds. Mark 37 specification, 8 to 12 seconds minimum. Hayes called Chen to his office at 1300 hours. Electrician's mate Chen, explain these timing records. Hayes spread the logs across his desk, the numbers undeniable. Chen had rehearsed this moment in his mind for 6 weeks. He could lie, claim instrument error, protect himself, or he could tell the truth and accept the consequences. He thought about his father's shop, about solving problems honestly even when honesty was difficult. I built an unauthorized parallel calculating circuit, sir. Electrical approximation system. Bypasses the mechanical integrators for initial solutions. 3-second response time, 85% accuracy. Hayes stared at him for a long moment. You modified $1 million fire control equipment without authorization? Yes, sir. Using salvaged components? Yes, sir. Do you understand this is a court-martial offense? Yes, sir. But it worked. And we're alive. Hayes examined the ghost circuit himself that afternoon, Chen explaining each component, each calculation, each risk he'd accepted. The fire control officer's expression shifted from anger to reluctant admiration as he traced the elegant solution Chen had improvised from scraps. This is brilliant engineering, Hayes said finally. It's also completely unauthorized. The report went up the chain of command with brutal efficiency. Ship's captain to task force commander to Admiral Halsey at South Pacific headquarters. Each level faced the same dilemma. Chen had violated regulations and possibly saved lives. Halsey's response came back within 48 hours. I don't care if he used Benjamin Franklin's kite string. It worked. Document the system. Bureau of Ordnance to evaluate immediately. Chen gets official reprimand and Navy Commendation Medal. Sometimes you need sailors who think faster than the regulations allow. Navy engineers arrived in late November, interviewed Chen for 3 days, documented every aspect of his circuit. By December, a modified version engineered for safety but identical in concept entered testing. Fleet-wide implementation began in March of 1943. Chen received his official reprimand on December 5th. His commendation medal arrived December 7th. Promoted to Electrician's mate first class and assigned to Bureau of Ordnance as technical consultant, he spent 1943 helping install his system across the Pacific Fleet. The statistical impact was measurable. American night fighting effectiveness improved dramatically. Ship losses in surface actions dropped by 60%. By mid-1943, American ships dominated night surface combat, using fire control systems based on principles an electrician's mate had improvised from salvaged parts. Post-war naval historians would document Chen's circuit as a pivotal tactical innovation. The Mark 37 modification traced directly to his unauthorized work. Modern fire control computers acknowledged their ancestry to one man's decision that survival mattered more than regulations. Chen retired as chief electrician's mate in 1955. He returned to his father's shop in San Francisco, repairing radios and teaching apprentices. When they asked about his Navy service, he told them about November 13, 1942, about the 12-second problem and the 3-second solution. His lesson was simple. The best engineering happens when you understand the problem completely and have the courage to fix it. Even if the regulations say wait. Especially then.